Alrighty, everybody. I just got the okay to start our planetarium show. So I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh, pretty cool. And once again, everybody, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I'm going to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls, I'm actually a person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one enormous screen. Thanks to help of 6 different projectors hiding throughout our planetarium dome. If you're looking for those projectors, we got 2 in the very front, 2 in the middle, and 2 at the very top of our dome, just below that purple glow. And just to let you know, folks, the show that we're going to be doing right now is different from all the other previous shows that we've done here in the Morrison Planetarium. This show is called Tour of the Universe, and this show is completely live, which means you're going to be hearing my voice for the next 30 minutes. And pretty much what this whole show entails, we're going to be starting off pretty close to Earth, and we're going to be zooming all the way out to the very edge of the observable universe. Just a heads up, I just want to let you know that hopefully you won't have an existential crisis at the end of the show because we are very, very small in the grand scheme of things. So just a heads up. And before we get started, folks, I do need to go over some quick house rules just so that we're all on the same page. We can have a great experience in the planetarium. There's a few of us in here right now. First off, there's no food or drinks allowed inside. So if you manage to bring any snacks or beverages, make sure those are tucked away to the very end of the show. We want to keep the theater nice and clean for all of our guests coming in today and in the future. And also, folks, please no feetsies on the seatsies because again, we want to make sure the seats stay nice and clean. So make sure those feet are on the floor and not on the seats. We do appreciate your help. And also, folks, if you happen to have any of these fancy 21st century gadgets like cell phones, smartwatches, tablets, anything that produces bright white light or loud sound, now's the perfect time to turn them off, deactivate them, put them away for the next 30 minutes, as these could be very distracting not only for yourself, but for the folks sitting behind you. And not only that, everybody can see what you're looking at on your phone that's above you. So, yeah, that is that as well. And then also, folks, the biggest of them all, please remember to wear your mask at all times while we're in the planetarium dome above your nose. People tend to forget that they breathe out of their nostrils, so make sure those nostrils are covered up. We're going to be here for about 30 minutes. Looks like there's at least 100 of us in here. So, again, 100 of us in here for 30 minutes. Please wear your mask out. Thank you so much. And also, folks, if you do need to exit during our planetarium show, you're more than welcome to do so. All we ask is that you exit at the very top of the planetarium dome. That's where the exits are going to be before, during, and after the show. So, when in doubt, always make your way up the stairs, not down them. And last but not least, folks, this show is very immersive thanks to our 70-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy way to ground yourself. All you got to do is close your eyes, take a few big deep breaths, and your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. But with that being said, it looks like we're ready to go. And let's just make sure all those cell phones are put away, and we'll begin our tour of the universe, y'all. All righty, everybody. As I mentioned, we're going to be starting off pretty close to home, but not exactly right at the Earth. We could see the Earth just below this contraption. And what we're looking at right now, folks, is something called the International Space Station, or what we like to shorten it by calling it the ISS. Now, a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in the news or in articles, but I don't know what it is. Well, to let you know, folks, the International Space Station is a collaboration between many nations across our planet Earth. And pretty much all these nations want to figure out what happens to stuff in space. So, the International Space Station is a large laboratory or research facility that's orbiting around our planet. And they conduct all sorts of different experiments up here that they can't normally do on our Earth because up here there's less gravity. And some of the different experiments that they'll conduct up here are things like what happens when you try to spark, or what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently? What happens when you try to spark a match in space? Does the flame act the same? Does it act differently? One of my other favorite ones is that they had 2 identical twins. One twin lived on the Earth for a year, the other one lived on the International Space Station for a year. And after that year, they compared and contrasted. Turns out the only difference of living in space is that you age a little bit slower. And you also have a lot less body mass index. You have less muscles because you don't have gravity constantly working down on your muscles. So if you're going to go live in space for a long period of time, make sure you exercise daily. Hee hee hee. And folks, right now the International Space Station looks enormous on our screen, but it's not that big in truth. The International Space Station is only about the size of an American football field. So if you've never been to an American football game, you can also use the whole California Academy of Sciences, the museum that we're in today. That's how big the International Space Station is. And also, folks, this thing is going incredibly fast. The International Space Station goes a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And to tell you the truth, folks, the International Space Station isn't too far away from the Earth either. It's only about 225 miles above the surface of our Earth. 225 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. And also, this is as far as we put humans into space nowadays because traveling into space gets quite costly. So, only 225 miles above the Earth. And the reason why it's so costly is because one, you have to get your hands on a rocket ship, and two, you have to build yourself a rocket ship. And then you also have to account for all the rocket fuel, all the rocket gas you're going to be needing while you're going to get up here in space. And just to tell you, gas prices aren't the best right now. So just a heads up. Hee hee hee. And then not only that, you also account for all the food, water, and all the air you're going to be breathing up here. So the bill starts to get quite costly quite rapidly. But let's leave the International Space Station, y'all, because this is just our first stop on our tour of the universe. And it looks like we're just hovering just off the California coast. We can see Los Angeles down below us. I can see Catalina Island right down yonder. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can keep track of it. So we have a nice little orange line representing where the International Space Station is. And just to let you know, folks, the space program that I'm using here in our planetarium dome is something that you can go home and download if you like, and if you want to fly through space, just like how I am. The space program that I'm using right now is something called OpenSpace Project. So if you go to home to your favorite search engine, type in OpenSpace Project, you can download this and fly how I am. But just a heads up, OpenSpace isn't completely finished. It's in its beta phase, which means is that we'll come across a few bugs or glitches here and there. If we do, I'll point them out and we can try to look past them. And also just a heads up, OpenSpace uses a whole lot of processing power and information. So I wouldn't recommend downloading this if you have an older computer. Maybe if you have a newer one or a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't like to download stuff, we have another great option called NASA's Eyes. So go to your favorite search engine, type in NASA's Eyes, just like the human eyeball, and you'll be able to fly through space just like how I am without having to download anything. Easy breezy. But let's leave our Earth behind because now we're going to be making our way over to our nearest natural neighbor to us in space, the moon. Now, just to let you know, folks, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they also had some fun. They got to play some golf up here as well. But again, the last time we sent humans to the moon was a little more than 50 years ago or so quite a while. But don't worry, NASA has a new space mission in the works that's going to be sending humans to the moon in the next few years. This new space mission is called Artemis, which is pretty funny to say because Artemis is the sister to Apollo in Greek mythology. NASA's very clever at coming up with these space names. But what's the whole purpose of Artemis? Well, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we need to figure out how exactly we're going to live out here in space. So the moon is a perfect stepping stone to figure out all the logistics, how we're going to live out here in space. And what's also really cool about Artemis is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases all around the moon. Pretty much, we want to learn more about the moon. Our technology has improved in the past 50 years, so we want to look at new things that we weren't able to look at in those 6 space missions. So maybe they want to set up a lunar base over here by this crater. Maybe they want to check that out. Maybe they want to go check out the high mountains of the moon somewhere over here. They'll set up a lunar base over there. Maybe they want to go check out some lava tubes that they weren't able to take a look at, and maybe they'll set up a base over there. But what's also really cool is that with Artemis, they're also going to have a space station that's orbiting around the moon at all times, which is going to be called Lunar Gateway. So just like how we saw with the International Space Station, they'll have a space station going around. In case anything was to go wrong for those astronauts on the surface, they can launch off the moon surface and head to that space station where they would be safe. But again, look out for any news in the coming years about Artemis. We humans should be returning. Cross my fingers. Hopefully nothing goes wrong. And folks, when we look up here at the moon from Earth, the moon sometimes feels incredibly close to us, especially when it's close to the horizon. But the moon's incredibly far away from us. The moon's roughly about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it. The roads out here are poorly maintained. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. We'll see you later. So cute. And folks, we're going to be heading on to a much larger realm of our solar system because now we're going to watch the moon and the Earth as they slowly recede. In fact, let me turn on the planet trails because I can easily lose stuff out here in space. There we go. And not only that, folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace showing us the most accurate information and images to us. And now the nearest star to us should be coming into view. Here comes the sun. Do. And just to let you know, folks, our sun is incredibly far away from us. It's roughly about 93 million miles away from the Earth. So again, we're the third rock from the sun on the right-hand side. That's us. That's the sun, 93 million miles between us. But that's not that far in terms of speed of light. In order for light to reach us from the sun, it takes it only about 8.5 minutes at the speed of light to cross that 93 million miles away. Now, that's a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, we wouldn't know about it here on Earth for about 8.5 minutes because that last bit of sunlight would be emitted. It would travel that 93 million miles, 8.5 minutes at the speed of light, and then all of a sudden the daytime would become nighttime. And again, this concept is great because this works for really far away objects as well. For example, let's say we're looking at a star, let's say this one over here, that's 70 light years away from us. Well, we're looking at that star as it looked like 70 years ago because that light that traveled that 70 years just reached us. So when we're looking at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye perspective of our solar system, I'm going to do a quick refresher and name all the stuff in our solar system, just so we know. And of course, right in the middle, we have our star, the sun. The closest planet to the sun, we've got Mercury. Then we have Venus. Then Earth, that's us. And then we have Mars. These are the rocky terrestrial planets. These are places we can land an actual spacecraft on. And then beyond the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if we were to highlight all those asteroids in the asteroid belt. There they are. Now, one of my favorite things is that the asteroid belt was discovered in the early 1800s by a European astronomy group, and they called themselves the Celestial Police, which kind of sounds like something out of Doctor Who in my opinion. And then past the asteroid belt, we have the really big planets, the gas giants. We've got the Jovians. We've got Jupiter, Saturn, and then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And then Of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto right on the top of our screen. Now, just to let you know, folks, Pluto is no longer considered a planet. And a lot of people tend to ask me, Christian, why is Pluto no longer a planet? I love Pluto. I learned about it in school. It's still a planet to me. Viva la Pluto. Well, you see, folks, Pluto hangs out here in this outer part of our solar system past the orbit of Neptune in a region called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt's going to be all this stuff. So again, what we're looking at now is the Kuiper Belt, and we found more than 400 objects out here, way past the orbit of Neptune. Mostly, what you're going to find out here are icy asteroids and short period comets, comets that don't go too far away from the sun. And in 2006, we found more than 400 objects out here in the Kuiper Belt region, so we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And one of the things is that you need to be so big and so massive that you push all the other stuff out of your way. And unfortunately for Pluto, it didn't pass that criteria test because it does its own dance with Charon. So that's why it got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, folks. There's quite a few dwarf planets out here in the Kuiper Belt region. We've got Makemake, Haumea, Aries, and then closer to us in the main asteroid belt, we have Ceres. So it's kind of like Pluto said, hey, you kicked me out of your club. I'm going to start my own club, the dwarf planets. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And right now, folks, I'm going to be adding on screen some of the different spacecrafts that we sent out in the 1970s to explore our solar system. So here comes the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction right over there. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. Now, in order for light to travel all the way out here to the orbit of Pluto, it's going to take light about 5 hours at the speed of light to get this far. So a good distance away. But let's leave our planetary system behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now is going to become so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And let me just make sure my calculations are correct. So right in the middle, that's our solar system. A little bit down to the left, that's the nearest star system to us, Alpha Centauri. And again, 4 years at the speed of light just to reach the next star system to us. But 4 years at the speed of light doesn't really put into perspective of how long it would take us to travel that distance. Well, if you were to get in a rocket ship today and left our Earth, it's going to take you about 8,500 years just to get to the next star system to us. And that's just a one-way trip, y'all. But let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we are now inside the radiosphere, y'all, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they travel at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? And right now, folks, I'm going to be adding some markers onto the screen. These markers represent some of the many thousands of stars astronomers have discovered over the last 22 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found close to 5,000 exoplanets just in the nearby vicinity to us in space, and that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if we spin around in a good direction, we'll be able to see that we pointed our telescopes in one direction and we found a whole heap of exoplanets just looking in one direction. So that 5,000 number is going to be increasing as those years continue. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we can't answer that question quite yet. Pretty much, we have new space telescopes that are being developed right now, so it's going to be a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in this star system right over here. We find an alien civilization on the other side right here, 60 light years away from us. We shoot them a text message. We say hi, takes 60 years to get to them. They listen in, answer back another 60 years. That is a 120-year conversation in the making. Whew, and I could barely wait for a text message from my friend. But folks, of course, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet marker, because there's just a lot of them, but I want to leave our radiosphere up on screen. As huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. So let's leave that radiosphere behind. Alrighty, can anybody see their house from here? Just kidding. So again, we are now looking down at our Milky Way galaxy, and our Milky Way galaxy is incredibly large, folks. If you wanted to cross our galaxy from one side to the other, it's going to take you about 130,000 years at the speed of light. Whew, that is a good distance. And what's also really cool is that our solar system is orbiting around the galactic center of the galaxy center, and it takes our solar system about 11 million years just to orbit once around the galaxy center. And so far today, we estimate that our solar system has only gone around the center 14 times. So if you want to think about it in birthdays, like humans, how we talk about going around the sun, well, we're talking about going around the center. You can say our solar system is like 14 years in a sense. Pretty cool. And not only that, folks, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I do want to show you the shape of it from a sideways perspective. When we want to learn about the universe, it's so much more easier for us to point our telescopes and equipment galactically north and galactically south, instead of looking through the flat plane of our Milky Way galaxy, which has gas, debris, planets, stars, black holes, things that obscure our views of the universe. So again, we like to point our telescopes galactically north and galactically south, instead of looking through that plane of the Milky Way. That's going to come important later on in the show. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, we're now going to see a view where each point of light no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps even trillions of stars. Now, we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue zooming out, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or voids in space. So we can see a nice galaxy cluster right here. We can see a nice other galaxy cluster just a little bit below. We can see some voids in space where there's very few galaxies up here on the top left. So you can kind of think of galaxies like people. They like to hang out together in groups, or they like to avoid each other. And folks, we've zoomed so far back now that this picture that we're looking at represents the closest 30,000 galaxies to us in space, over 300 million light years across. We've got to give thanks to an amazing astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii and compiled this amazing representation thanks to the work of dozens of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tolley. I love flying through this galactic map. But folks, we now have automated systems that are mapping even the most distant galaxies. So now let's press back, and now we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star, that's an individual galaxy. Whew, I feel small. And just a heads up, folks, the universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in the flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way, it would line up just like so down the middle. So we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that we are able to find galaxies through the plane of our Milky Way. So you can see this nice purple survey right over here. You'll notice that they were still able to find galaxies, just not as much and not as far. Pretty much we have to wait for our technology to improve, and then we'll be able to fill in these dark gaps that haven't been mapped out yet. So it's just a matter of time. We just have to wait for that technology to be developed. But folks, it looks like we're running close out of time on our tour. 30 minutes is just not enough time to talk about the universe, so let's continue pressing out. And now we're going to be coming across these objects on the outer part of the large-scale structure of the universe called the quasars. So the quasars are going to be represented in orange right over here on the left side and on the right side. And the quasars are short for quasi-stellar radio sources. And these objects are blazing hot, and they're all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, folks. So we've made it to the very edge of the observable universe, and what we're looking at is something called the cosmic microwave background image, or the CMB image for short. Now, all evidence indicates that the universe that we live in is about 13.8 billion years old, and this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo either, but instead a temperature density image, where the light echoes of the Big Bang are color coded, with the light areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. And these fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, these tiny differences gave rise to the large scale structure of the universe, that clumping and clustering of galaxies that we saw everywhere just moments ago. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go. That's going to be back home towards Earth. So let's find a nice entry point through all these quasars and galaxies. And let's make our return trip back to planet Earth, folks. Alrighty, here we go. Alrighty, folks, we're across an expanse of over 13 billion light years, and we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're just making our way back into our Milky Way galaxy. It looks like we're heading straight for that radiosphere. And of course, we are making our way downtown, walking fast faces past, and we're homebound. Dun-dun-dun-dun-dun-dun. And we are now entering our star system, passing those spacecrafts that we sent out in the 1970s to explore our solar system, passing the Kuiper Belt, passing our main asteroid belt, heading to the third rock from the sun, though the only place we humans have ever lived and reside out here in the universe. And it looks like we're just about to pass the orbit of the moon, the furthest we've ever sent humans out into space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching with me today. I hope you did enjoy it. But with that being said, that's the end of our show. And I want to thank you again for stopping by. Have a good day, y'all. Take care.